Hello everyone. Today I would like to talk about multiple choice questions MCQ step-by-step guide series chemical bonding. Let's go and find out questions. Question number 1. Which of the following types of bonding involves sharing of electrons between atoms? Electrons share between atoms only in the covalent bonds. Which type of chemical bonds do atoms transfer electrons from one atom to another? So electron transfer from metal to non-metal when we are making ionic bonds. Question 3. Which of the following molecule is example of a compound with polar covalent bonds? The bond polarity we need electronegativity values. If the electronegativity values less than 0.5 we call bond is non-polar. Between 0.5 and 1.9 bond is polar, but both are covalent, electron sharing, non-polar covalent or polar covalent. In the bond electronegativity difference is greater than 1.9, then no longer electron sharing between atoms. It is electron transferring, so it is ionic. Among these given choices, C2H6, all bonds are non-polar covalent, less than 0.5 difference. Sodium chloride is greater than 1.9, it is ionic. CH4 is a non-polar covalent, all CH bonds, if you calculate the difference, 0.4. H2O is only polar molecule here. So H2O containing both OH2OH bonds, they are polar, greater than 0.5 but less than 1.9. What type of intermolecular force is primarily responsible for the high boiling point of water? There are three types of intermolecular interactions mainly: hydrogen bond, London dispersion forces and dipole-dipole interactions. Among these three, hydrogen bond is the strongest, dipole-dipole interaction is the second largest, and London dispersion force is the weakest. Water molecule showing unusual properties due to the presence of hydrogen bonds. Water has high boiling points and melting points, high specific heat capacity, and high heat of vaporization, and also high surface tension due to the presence of hydrogen bonding. Next question. Which of the following is true about metallic bonds? Metallic bond is a type of chemical bond that occurs between atoms of metallic elements. It is characterized by pooling of valence electrons shared among a lattice of metal ions. So these metallic bonds create a sea of electrons, the pool of electrons. Among these given answers, the answer should be the occur results from the attraction between positive metal ions and a sea of delocalized electrons. Question number 6. Which type of bond is characterized by the equal sharing of electrons between two atoms? Sharing electrons, if you consider this word, it is covalent bonds. Covalent bonds, there are two types, polar covalent and non-polar covalent. Polar covalent bonds meaning is electrons are unequally shared between atoms. Electrons move closer to the most electronegative element. Then the bond is polar. Non-polar covalent means electrons share equally between atoms. The question asks about equal sharing of electrons between atoms. Then it should be non-polar covalent bond. Next question. In molecule of carbon dioxide, CO2, what type of bond exists between carbon and the oxygen atoms? If you draw a Lewis structure for CO2, it looks like this. Double bonded oxygen with carbon and two lone pairs on each oxygen. These are covalent bonds between carbon and oxygen. Question number 8. Which of the following statements about hybridization is correct? There are different types of hybridization we discussed: sp, sp2, sp3, sp3d and sp3d2, mainly 5 hybridizations. You can see for each hybridizations in this table the geometry, the shape of the molecules. sp hybridization for linear molecules, linear geometry. sp2 hybridization, trigonal planar like BF3, BCl3. sp3 hybridization for tetrahedral shape, for example CH4 methane. sp3d for trigonal bipyramidal geometry, for example PCl5, and sp3d2 octahedral geometry like SF6. Now the question is, which statement is correct? The first one, sp3 hybridization occurs in molecules with linear shape, that is incorrect. Second one, sp2 hybridization involves mixing of 1s orbital and 2p orbitals, that is correct. sp2 meaning is 1s and 2p orbitals mixed together. Total orbitals mixing 3, then there are 3 sp2 hybridized orbitals formed. C. sp hybridization result in tetrahedral molecular geometry. So sp hybridization result linear geometry. And D. sp3d hybridization involves the mixing of 1s orbital and 3p orbitals. That is incorrect. sp3d is mixing of 1s 3p orbitals with 1d orbital. Total 5 orbitals mixed to make 5 hybridized orbitals. So the answer is B. sp2 hybridization involve 1s and 2p orbital mixing. Let's move on to next question. Which of the following describes a sigma bond? There are two types of bonds, sigma bond and the pi bonds. A sigma bond is a type of covalent bond that is formed by head-on overlap of atomic orbitals. All single bonds we consider sigma bonds. If we take a double bond that contains one sigma and one pi bonds, and triple bonds that containing two pi bonds and one sigma bonds. Now let's move on to the answers. First answer, a bond formed by the head-on overlap of atomic orbitals. So that is the correct definition for sigma bond. Second one, the bond formed by side-by-side overlap of atomic orbitals. So that is the definition for pi bonds. Side-by-side overlap form pi bonds. Pi bonds present only in double and the triple bonds. C and D statements also incorrect. So answer A. Question number 10. Which molecule has a trigonal planar geometry? Trigonal planar geometry meaning is there should be 3 bonds and 0 lone pairs. If we take one by one, CH4 carbon is the central atom, 4 hydrogens attached to carbon. So it is tetrahedral geometry, 4 bonds and 0 lone pairs. NH3. NH3 ammonia, nitrogen is the central atom. If you draw the Lewis structure, there are 3 hydrogens attached to nitrogen but with lone pair on nitrogen. That is trigonal pyramidal geometry. BF3. BF3, boron attached to 3 fluorine atoms. 3 bonds and 0 lone pairs, that is trigonal planar geometry. Last one, H2O. H2O molecule, oxygen is the central. There are 2 hydrogens attached, 2 bonds and 2 lone pairs on oxygen. That is bent shape, or we call angular shape. Question number 11. Which of the following molecules has the highest dipole moment? CO2, carbon dioxide, CH4 methane and CCl4, carbon tetrachloride. If we consider the electronegativity difference, bond polarity of these molecules, carbon dioxide, carbon-oxygen bonds are polar. However, with symmetric shape, each carbon-oxygen bond dipoles are opposite in direction, equal in magnitude. They cancel each other. Therefore, the overall molecule is nonpolar. Dipole moment is 0. CH4. If we consider methane CH bonds, all CH bonds are nonpolar. So overall molecule is nonpolar. CCl4, carbon tetrachloride. It is tetrahedral geometry. Individual bonds, CCl bonds are polar. However, with symmetric shape, each dipoles opposite in direction and they are equal in magnitudes. So they cancel each other, become the overall molecule become nonpolar. So dipole moment is present only in H2O molecule, water molecule among these given choices that has the highest dipole moment greater than 0. Question number 12. In which of the following molecules does the central atom violate the octet rule? Octet rule. Octet rule means the central atom is surrounded by 8 electrons. So there are a few violations. The one is hydrogens. The other one is beryllium and boron compounds violates the octet rule. They can hold, the beryllium and the boron compounds can hold less than 8 electrons. And in 3D series, phosphorus and sulfur, another examples. Some phosphorus and some of the sulfur compounds can hold more than 8 electrons in the presence of their d electrons. Therefore, they violate the octet rule. So among these given choices, BF3, central atom boron surrounded by only 6 electrons, less than octet. Which type of hybridization is found in the central atom SF6? SF6 is octahedral molecule. Sulfur is the central atom. There are 6 fluorine atoms attached to sulfur. SF6 is octahedral geometry sp3d2 hybridization. Question number 40. What is the bond order of oxygen-oxygen bond in diatomic oxygen molecule? Molecular orbital diagram only for the p electrons. One oxygen atom's electron configuration 1s2, 2s2, 2p4. Another oxygen atom's p4. Both p4 if we add together total electrons 8. So let's occupy 8 electrons from lowest energy molecular orbitals to the highest energies. After we occupied electrons in molecular orbitals in the middle, 6 electrons in bonding molecular orbitals and 2 electrons in anti-bonding 5'2p molecular orbitals. So let's apply the formula. Bond order is equal half times number of bonding electrons minus number of anti-bonding electrons. Here you can see 6 in bonding molecular orbitals, 2 in anti-bonding molecular orbitals. 6 minus 2 is 4. 4 divided by 2 is 2. Bond order for oxygen diatomic molecule is 2. Next, which of the following statements about the resonance structure is true? What is the meaning of resonance? Resonance means all possible Lewis structure for given molecule or ion. So these resonance structures, atomic arrangement should be same. The only difference is the position of the electrons, not the atoms. Which of the following pairs of elements is most likely to form ionic bonds? We discussed mainly ionic and the covalent. There are two types of bonds. Ionic bonds formed by transfer electrons from metal to nonmetal. Covalent bonds arise between nonmetals. Among these given answer, let's see which combination is metal-nonmetal combination. First one, carbon and oxygen. Both are nonmetals. Between carbon and oxygen, covalent bond, nitrogen and hydrogen. Again, both are nonmetals. It should be covalent. Next one, sodium and chlorine. Sodium is a metal, group 1 metal. Chlorine is a nonmetal. Metal, nonmetal, then we can form ionic bond. And last one, sulfur and fluorine. Both are nonmetals. It form covalent bonds. Ionic bonds always form metal-nonmetal. So if you check metal-nonmetal combination, it should be ionic bond. Question number 17. How does the bond energy change as bond order increases? Bond order increases, the bond energy also increase. High bond order involve more shared electrons between atoms. Therefore, it strengthens the bond. Which of the following molecule is non-polar despite having polar bonds? If you draw a Lewis structure for these four molecules, H2O, both OH bonds are polar and the overall molecule is polar. H2O is a bent or angular shape. CH3Cl. CH bonds are non-polar, but CCl bond is only polar bonds. If any molecules containing one polar bonds, the overall molecule is polar. CCl4. All four CCl bonds are polar, but with symmetric shape in CCl4. It is tetrahedral. The individual bond dipoles are equal in magnitude and opposite in directions. They cancel each other. So the overall CCl4 molecule becomes nonpolar. NH3. All three NH bonds are polar and the dipoles are towards the nitrogen. So there is a net dipole moment in NH3 molecule. It is a polar molecule. Next one. In a molecule of PCl5, what are the bond angles around the phosphorus atom? PCl5 is trigonal bipyramidal in shape and sp3d hybridization. You can see using this color coding, 2 chlorine atoms are in axial positions and 3 chlorine atoms are in equatorial positions. There are 3 types of bond angles present in the PCl5. Equatorial phosphorus equatorial bond angle, ClPCl. The bond angle is 120. And if you consider axial phosphorus axial bond angle, that is 180 degrees. And if you consider one chlorine atoms in the axial position, phosphorus atoms equatorial, bond angle is 90 degrees. There are 3 types of bond angles present in PCl5, 90, 120 and 180. Which of the following has the shortest bond length? So we discuss single, double and the triple bonds. Stronger the bond, shorter the bond. So among the single, double and the triple, shorter bond is triple bond. However, it is the strongest bond. Single bond is the weakest bond and it is the longest bond. Single bond length is the largest and the strength is the weakest. Triple bond length is the shortest but it is the strongest bond. In the context of molecular orbital theory, what is the bond order of C2 molecule? C2 means 12 electrons total. One carbon is 6 electrons, so C2 total 12 electrons filled from lowest energy to the highest energy molecular orbitals. If you draw the molecular orbital diagrams for the p electrons, one carbon atom configuration is 1s2, 2s2, 2p2. So we draw this diagram only for the p electrons because 1s and 2s electrons, they become equal to 0. So P2, 2 electrons in one carbon, and the right hand side another carbon atoms P2. In the middle we can see molecular orbitals. So total 4 electrons from both carbon atoms gets filled from lowest energy to the highest energy. 2 electrons in sigma 2p and 2 electrons in pi 2p. So if you apply to the equation, bond order is equal half times number of bonding electrons minus number of anti-bonding electrons. Bond order is 2. Half times 4 in bonding electrons, no electrons in anti-bonding orbitals, tau orbitals. Then bond order become 2 for C2 molecule. Next question. Which of the following molecular orbitals will be the lowest in energy for the diatomic molecule formed from second row elements? Second row elements is from lithium to neon. In the molecular orbital theory, diatomic molecules formed from second row elements like N2, C2, O2, 1, sigma 1, 2 is bonding molecular orbital should be the lowest in energy. However, among these given choices, sigma 2s is the lowest energy. So electron filling you can say sigma 1s, sigma star 1s and sigma 2s sigma star 2s, and so on. So the lowest energy among these given choices, sigma 2s. Next question. Which of the following is true about the molecular orbital diagram of oxygen, diatomic O2? If we consider molecular orbital diagram for p electrons, oxygen electron configuration is 1s2, 2s2, 2p4. So one oxygen's p4 electrons and the other oxygen's p4. Total is 8 electrons. If you fill the electrons, sigma 2p, pi 2p completely filled and two more electrons singly occupied in pi star 2p anti-bonding orbitals. Now let's go to the answers. It has two unpaired electrons in pi star 2p orbital. Statement is correct. Next, the bond order is 1. But if you calculate the bond order, it is not 1, bond order is 2. All molecular orbitals are fully filled. Incorrect. The highest occupied molecular orbital, or we simply say HOMO, is sigma 2p. Here, the highest occupied molecular orbital is pi star 2p. So, statement D also incorrect. Then the answer is A. It has two unpaired electrons in the anti-bonding pi star 2p orbitals. Question number 24. Considering the Whisper theory, OVS EPR theory, which of the following molecule has a seesaw molecular geometry? If you consider the shape of the given answers, SF4 is having seesaw shape, or we call distorted tetrahedron. Seesaw shape, there are 4 bonds and 1 lone pair on the central sulfur atom. 4 bonds and 1 lone pair we call seesaw shape or distorted tetrahedron. Which type of intermolecular force is primarily responsible for high boiling point of water? There are 3 types of intermolecular interactions, mainly hydrogen bonds, dipole-dipole interactions, and London dispersion forces. Among these 3, London dispersion forces is the weakest one. The second stronger is dipole-dipole interactions, and the strongest intermolecular interaction is hydrogen bonding. Water is having the unusual properties due to this presence of hydrogen bonding. Question 26. Which of the following species has the highest lattice energy? We can explain lattice energy using Coulomb's law. The lattice energy increases with increasing the charge on the ions, and lattice energy increases as the size of the ion decreases. The reason is, according to Coulomb's law, lattice energy directly proportional to the charge on the ions, and it is inversely proportional to the distance or the radius of the ions. If we consider the given answers, first one sodium chloride, charges are +1 and -1. Potassium bromide, again +1 on the potassium, bromide Br -1. Magnesium oxide, magnesium charge +2, oxygen is -2. Cesium iodide, cesium in group 1, so +1, iodine, iodide -1. If you consider the charge, the greater the charge in magnesium oxide, it has greater lattice energy compared to the other 3 compounds. Which hybridization scheme is expected for the central atom in IF7? You can see IF7 meaning is there are 7 bonds surrounded by the central atom iodine. sp3 for tetrahedral, sp3d trigonal bipyramidal shape, and sp3d2 is for octahedral. Therefore, the 7 bonds need the 7 orbital mixing. Among these given choices, it should be sp3d3. There are 7 orbitals, 1s and 3p orbitals and 3d orbitals mixed together to make 7 hybridized orbitals. What is the formal charge on sulfur atom in the sulfate anion? Let's try to draw sulfate and iron Lewis structure. Sulfur is the central atom and then two oxygens double bonded and two oxygens single bonded. Charge on the iron is 2 minus. So what is the formula to calculate formal charge? Formal charge is equal valence electrons on the atom minus lone pair electrons minus half times bonding electrons. So here we need to focus on sulfur. Sulfur valence electron, sulfur is in group 6 valence electron. Group number is equal to the valency count minus lone pair electrons on the sulfur. In the given Lewis structure, lone pair electron 0 minus half times bonding electrons. Two double bonds. So one double bond means 4 electrons. So two double bonds contributes 8 electrons plus two single bonds. The total 12 electrons in bonding. So 6 minus 0 is 6 minus half times 12 is 6. So 6 minus 6 is 0. Formal charge on sulfur is 0. The same way if you want you can practice calculating formal charge on each oxygen. And then you can see single bonded oxygen, each oxygen get formal charge -1 and double bonded oxygen formal charge 0. Question number 29. Which of the following statements about the pi bonds is true? We discussed there are two types of bonds, sigma bonds and the pi bonds. Sigma bonds, all single bonds are sigma. Pi bonds present only in the double bonds and the triple bonds. Pi bonds are weaker than sigma bonds. The reason is pi bonds arise by sideway overlap of the p orbitals. And pi bonds restrict rotation around the bond axis. But sigma bonds allows free rotation along the bond axis. Pi bonds occur in double and triple bonds. Which molecule exhibit sp hybridization? If you draw the Lewis structure for each given answer, C2H4 we call ethylene. It is trigonal planar geometry around one carbon atom, double bond between carbon and carbon. C2H2 acetylene. It is linear molecule, triple bond between carbon and carbon. Linear geometry is sp hybridized, so each carbon is sp hybridized carbon. CH4 tetrahedral geometry, sp3 hybridization. NH3 again sp3 hybridization, but it is trigonal pyramidal shape. What is the geometry and hybridization of carbon atoms in benzene? C6H6. If you draw the benzene structure, it looks like hexagonal structure and there are three double bonds. Each carbon has one hydrogen atoms connected. You can clearly see the bonding environment around one carbon atoms, one double bond and two other single bonds. One single bond connected to the adjacent carbon atom and the one bond formed with hydrogen. There are three bonds, three electron groups, zero lone pairs on each carbon. This is trigonal planar geometry around each carbon. Trigonal planar geometry is for sp2 hybridized. So answer A, trigonal planar sp2 hybridization. Which statement correctly describes the relationship between bond length and bond energy? The concept here is shorter the bond, the greater the bond strength. So let's discuss single bonds, double bonds and the triple bonds. Single bonds, only two electrons sharing between atoms. Single bond length is larger, but bond is weaker. Double bond means there are four electrons sharing between atoms. Double bond is shorter than the single bond. Triple bond. Triple bond is the shortest bond. There are six electrons sharing between atoms, but triple bond is the strongest bond. Triple bond is the stronger, the second stronger is double bond and weaker bond is single bond, but bond length the opposite direction. Which of the following statement is true about the bonding in NH4+, ammonium plus iron? Ammonium plus ion is tetrahedral geometry. If you draw a Lewis structure of ammonia NH3, 3 bonds and 1 lone pair on nitrogen. So this 1 lone pair on nitrogen can contribute to make another NH bonds with incoming H plus ions. Then that is tetrahedral geometry sp3 hybridization. Let's see what is the answer. They involves dsp3 hybridization. The first answer, it is incorrect. Second one, nitrogen atom has one lone pair. No, the one lone pair already used to make NH new bond. All NH bonds are identical in length and strength. Last one, it exhibits trigonal pyramidal geometry. This exhibits tetrahedral geometry. The answer is, among these given choices, the best choice is all NH bonds are identical in length and strength. Which of the following diatomic molecule has the strongest bond? Nitrogen, nitrogen, triple bond. Oxygen, oxygen, oxygen diatomic molecule, double bond. And fluorine and chlorine form single bonds. The same concept we applied for question number 32. Stronger the bond, shorter the bond. Nitrogen, nitrogen, triple bond is the strongest bond, but it is the shortest bond. This is how bond strength vary. Bond strength increases from single to triple, but bond length is decreases from single to triple. Longer bond is single, shorter bond is triple. Last question. Which of the following ion is expected to have smallest ionic radius? These cations formed by losing electrons. When an atom loses one or more electrons to form a positive charge ions, we call cations. Then the effective nuclear charge. Effective nuclear charge is the net positive charge experienced by the remaining electrons increases. The reason is number of protons remain the same, only the electrons we remove. Therefore, the effective nuclear charge increases by forming the cations. As a result, the remaining electrons are pulled closer to the nucleus. Only fewer electrons, but still proton count is larger than the electron count. So more positive character in the nucleus, they pull electron towards the nucleus, leading to decrease in the ionic radius. They are shrinking the size. Thank you everyone for watching. If you find this helpful, subscribe to the channel for more learning.